In part 3, we're going to measure the voltage associated with connecting two half cells together. We're going to look at 6 different half cells. We're going to look at the half cell of copper and copper 2+. We're going to look at the half cell of zinc and zinc 2+. We're going to look at the half cell of tin and tin 2+. We're going to look at the half cell of iron and iron 2+, the half cell of lead and lead 2+, and finally the half cell of magnesium and magnesium 2+. So what I've done here is I've taken a piece of filter paper and I folded it into 6. I've cut out a chunk of the filter paper and placed the filter paper in a petri dish. In that petri dish, with each one of the half cells I'm interested in, I've placed copper metal, zinc metal, tin foil, an iron nail that's not galvanized, some lead metal, and a strip of magnesium. What I'm going to do now is I'm going to add to each of those metals a couple of drops of their respective cation solutions. So I'm going to start with 0.1 molar copper 2+, and I'm just going to add a couple of drops of copper 2+ on top of the metal in that section of filter paper. Next, I'm going to add a couple of drops of zinc 2+ near the zinc metal. I'm going to add a couple of drops of tin 2+ near the tin foil. I'm going to add a couple of drops of iron 2+ on top of the iron nail. I'm going to add a couple of drops of lead 2+ near the lead metal. And then finally a couple of drops of magnesium near the magnesium strip. At this point, I've created half cells. Yes, these are very tiny half cells, but the advantage of these very small half cells is that you're looking at solutions in which you don't have much material that you need to use. Remember, we're focusing on environmental chemistry this term, so it's great to use smaller amounts of material to demonstrate the concepts we want. In the middle of all of these solutions, I'm going to add a saturated solution of potassium chloride. Potassium chloride is meant to be our salt bridge. A salt bridge enables you to balance out charges as electrons are moving from an anode to a cathode.